we're going to work on writing the conclusion to a hypothesis test. So let's assume that you've written your hypotheses, you've calculated your test statistic, whether it's a z or t or a chi-squared, and you know its p-value. But you're still struggling with interpreting your test and writing your conclusion. Let's break down what you need to do into small, manageable steps. The first thing you need to do is make a decision to reject or fail to reject the null hypothesis. The basic rule is to go by the p-value you found. Remember that the p-value equals the probability of your sample results occurring by random chance if the null hypothesis is true. If the p-value is very small, it is extremely unlikely that the sample results occurred by chance. Since the sample results were unlikely, but they still occurred, it's probably the null hypothesis that is incorrect, so we reject it. Often we set a level of significance called alpha as a kind of fence post. If the p-value that we get from our test statistic is less than or equal to alpha, we're going to reject the null hypothesis. But if our p-value is greater than alpha, we're going to fail to reject it. Now, sometimes they don't give you a level of significance in the problem. That happens a lot on AP stats exams. So if there's no alpha given, what do you do? Well, let's try using a little common sense first. Chances are if they didn't give you an alpha, it's because the p-value is pretty obviously either really low or really high. And if the p-value is really low, reject the null hypothesis. Another thing you could do to help yourself out is use a common level of significance like 5% as a kind of mental fence post for decision making. The second thing we need to do is decide what effect that first decision we made about whether we reject or fail to reject the null has on the alternative hypothesis. If we rejected the null hypothesis, that means there was enough evidence to support the alternative. But if we failed to reject the null, then there wasn't enough evidence to support that alternative hypothesis. Now, you notice I'm talking about evidence. It's not us who decides whether we are going to support the alternative hypothesis or not. It's all about what the evidence shows you. If you have enough evidence to reject the null, you have enough evidence to support the alternative. And again, if you fail to reject the null hypothesis, it's because you didn't have enough evidence to support. So, the next thing we have to do is write it up. Now, a good conclusion is going to have 4 points, all of which are related. So the first thing I want you to do is, using the numbers in the problem, compare your p-value and your alpha. Now, if you don't have a level of significance given, then describe your p-value as being small enough or large enough to, wait for it, reject or fail to reject your null hypothesis. That would make a great starting sentence for your conclusion. Try this. The p-value, 0.002, is less than the 5% level of significance, so there's enough evidence to reject the null hypothesis. Right? One more sentence and we're done. So let's make our next 2 points. The third thing you want to do is state what you're going to do about the alternative hypothesis. So you want to talk about if there's enough evidence to support it, or if there's not enough. And we're going to finish by restating what that alternative hypothesis actually is. We're going to rewrite our alternative hypothesis in terms of the problem. So we're going to contextualize it. 1 or 2 sentences, and it's all over. You've written a conclusion. Let me give you a sample that kind of builds on my first sentence I gave you before. The p-value 0.002 is less than the 5% level of significance, so there's enough evidence to reject the null hypothesis. The evidence supports the claim that the student absentee rate is higher than 15% in June. Bam. Let's try a couple examples. So let's say you're asked to perform an appropriate test to determine if the proportion of male dogs adopted from rescue groups is lower than the proportion of female dogs. They give you all the stats you need to work with, and you decide to perform a 2-sample z-test for proportions. Let's say that your null hypothesis is that the proportion of male dogs is equal to the proportion of female dogs adopted. That our alternative would be that the proportion of male dogs adopted is less than the proportion of female dogs adopted. And let's say we run our test and we get a p-value of 0.382. So now we have to make our decisions. Decision number 1. Check out that p-value. Now, there was no alpha given, but still that p-value is pretty high. So we are going to fail to reject our null. And then because we failed to reject, that means that there's not enough evidence to support the alternative hypothesis. Now we just have to write it up. So you might pause a minute and try writing it yourself, and I'm going to show you my version. My conclusion is the p-value, 0.382, is relatively large, so there's not enough evidence to reject the null hypothesis. There is not sufficient evidence to suggest that the proportion of male dogs adopted from rescue groups is lower than the proportion of female dogs. I hope you had something similar to that. And you can always change things up a bit once you get really comfortable at doing this. For instance, your first sentence might be that the probability of getting these sample results is 38.2%, suggesting they may have occurred by random chance. You can change up the words, but you still have to say the same 4 things. And again, you notice that I took the language for my last sentence right out of the original problem. We'll do one more. You're asked to perform an appropriate test to determine if average daily temperature is a good predictor for ice cream sales. You choose a linear regression t-test. Your null hypothesis is that there's no association between temperature and sales, and your alternate is that there is an association between the variables. I wrote those 2 hypotheses symbolically too for people who prefer that. And let's say our p-value is 0.04. So decision time, I think we're going to reject and support, and write your conclusion now. The p-value of 0.14 is small enough to reject the null hypothesis. There's enough evidence to conclude that there is an association between temperature and sales. It seems that average daily temperature is a good prediction for ice cream sales. Now, I included that last sentence because I wanted to make sure that I answered the question that they asked me in the problem. So that's one extra step you have to take sometimes. Good luck.